Welcome to Tech Evaluate. In today's in-depth exploration, we'll delve into a pressing issue that significantly impacts the future of electric vehicles in the United States, the state of the U.S. power grid. Recent events, such as blackouts and grid failures, have raised critical questions about whether the power grid is adequately prepared to support the growing electric vehicle revolution. We'll dissect the complex challenges and propose potential solutions to ensure a seamless transition to an electric future. Why the U.S. power grid isn't ready for electric vehicles. First and foremost, let's gain a comprehensive understanding of why the U.S. power grid is currently ill-equipped to meet the demands of electric vehicles. The U.S. power grid, a sprawling system responsible for delivering electricity to our homes and businesses, often operates silently in the background. We hardly notice it when it functions smoothly, but when it falters, its impact reverberates across our daily lives. Outdated infrastructure is a critical issue, with a staggering 70% of the country's power transmission lines exceeding 25 years of age. These lines, designed with a typical lifespan of 50 years, are well past their prime. The aging infrastructure extends beyond transmission lines to the very transformers that make the grid function. The average transformer within the nation's grid system is over 40 years old, surpassing the recommended service lifespan of 30 to 50 years. As these transformers near the end of their operational life, the frequency of failures rises sharply. Consequently, the deteriorating grid infrastructure has led to a surge in power outages in recent years. While some of these failures stem from the inability of the aging grid to withstand severe weather events, they have profound consequences for electric vehicle owners, particularly during emergencies caused by weather-induced power outages. Power grids' constrained capacity may slow EVs adoption. Now, let's turn our attention to how the constrained capacity of the U.S. power grid threatens to impede the widespread adoption of electric vehicles. Electricity experts and officials are sounding the alarm, warning that many states may lack the necessary power supply to meet the growing demand in the months ahead. It's a dire prediction, especially considering that many of the nation's grid operators are failing to account for climate change in their planning. As more American households make the switch to electric appliances and electric cars, the power grid faces an increasingly heavy load, especially during peak demand hours. The result is an incessant stream of headlines and news reports highlighting the inadequacies of the U.S. power grid. The surge in electric vehicle adoption only exacerbates these challenges. Infrastructure and time required for EV charging. Another critical challenge lies in the infrastructure for electric vehicle charging. Charging an electric vehicle may seem straightforward, but the reality is complex. There are various types of chargers, each with its own characteristics and installation requirements. Level 1 chargers, for instance, operate on a 120-volt outlet and offer a relatively slow charging rate of around 4 miles per hour. These chargers are often the only option for some users due to limitations in electrical supply, which may depend on the age and accessibility of the building they reside in. Level 2 chargers, on the other hand, utilize a 240-volt outlet and can provide a significantly faster charging rate of about 32 miles per hour. These chargers offer more flexibility and are available in both indoor and outdoor variants. However, their installation can be costly and may be challenging, depending on the electrical infrastructure of homes and offices. DC fast chargers, requiring a 480-volt power source, offer the most rapid charging experience, with a staggering 540 miles of range gain per hour. However, not all electric vehicles are compatible with these chargers, and there are multiple connector types, including Tesla, CHAdeMO, and CCS, making electrical installation considerably more complex than level 1 and 2 chargers. Renewable energy going to waste. Beyond these challenges, renewable energy sometimes goes to waste due to grid congestion. Solar and wind power, two major renewable energy sources, are often curtailed when the grid becomes congested. This curtailment represents a significant loss because renewable energy production depends on weather conditions, like sunshine and wind. One solution to address this issue is to invest in energy storage solutions, such as batteries, which can store excess power rather than wasting it and overloading the grid. However, integrating these storage systems into the power grid is a substantial challenge. Grid relies on fossil fuel power plants. Furthermore, the U.S. power grid still relies heavily on fossil fuels, which presents a significant roadblock to the electrification of transportation. Only 19.8% of U.S. power from renewables in 2021. Although electric cars offer the potential to reduce carbon emissions in the transport sector, the grid continues to rely on fossil fuels for the majority of its power generation. This reliance on fossil fuels poses a serious obstacle to achieving a sustainable, low-carbon future. How can the power grid change to support electric vehicles? Now, let's explore the various solutions that could make the power grid more supportive of electric vehicles. One promising solution is to replace aging transmission lines with advanced conductors, which are more efficient and capable of carrying more power. This simple upgrade could potentially increase the grid's transmission capacity by 27 GW annually. In addition to upgrading existing infrastructure, the federal government is actively working on building new power transmission lines. While adding new capacity is the most effective way to address grid congestion, it comes with its share of challenges, including resistance from state and local stakeholders on site permitting. Furthermore, we can enhance the grid's support for electric vehicles by incorporating more renewable energy sources. Expanding the transmission capacity will allow more renewable electricity to flow into the grid, meeting the demands of electric vehicle charging. Microgrids, which are local energy grids with area control capability, can play a significant role in this transition. They can disconnect from the primary power grid and operate autonomously using local renewable energy sources such as wind or solar power. These microgrids are essential for efficient utilization of renewable energy. Are electric cars worth it? Finally, let's address a fundamental question: are electric cars a worthwhile investment? Owning an electric car offers several compelling advantages. Over their lifetime, electric cars tend to have lower ownership costs than conventional vehicles. With fewer moving parts, maintenance expenses are reduced, and fuel costs are minimal, leading to substantial savings for drivers. Furthermore, electric vehicles are environmentally friendly. Given that the transport sector is responsible for approximately 1/3 of America's carbon emissions, the transition to electric vehicles holds the promise of significantly reducing the country's carbon footprint. However, it's important to acknowledge that electric vehicles come with a higher upfront cost compared to traditional gasoline-powered vehicles. Additionally, the availability of charging infrastructure remains uneven, making electric vehicles more practical in certain areas than others. On a positive note, various purchase subsidies and rapid expansions of charging networks are making electric cars increasingly appealing and accessible to consumers across the country. The future of electric vehicles in the United States is intricately tied to the state of our power grid. While electric vehicles hold immense promise for a greener future, addressing grid infrastructure and capacity limitations and embracing renewable energy sources is crucial. If you found this video informative, please like, subscribe, and share it with others who share your interest in the future of electric vehicles. Stay tuned for more updates on this topic and other pressing issues at Tech Evaluate. Thank you for watching, and we'll see you next time.